Studio mode. Evan, can you add Evan Nekoya as an emote? How do you make that into an emote? Like, the emotes aren't big enough to show something beyond, like, my face. Like, I'll add more emotes if I get enough subscribers, because right now I'm capped at 1 emote per subscription level. What does timeout do? I mute you. Timeout means mute, so if you press that button, I will mute you for 10 minutes. No, I don't want to update my iPad. Go away, go away. No! No, stop updating everything. No, no. All right. Why do you want to mute yourself? I don't know. It was a suggested default award, so I don't know. Serena asked, when do you want to play set? Tell her I meant Hanabi and basically whenever I'm not streaming. Streaming is like the only thing I still have that's scheduled at a specific time. Where's my mouse? That's an important question. Okay. Okay, so to the left of the graph. Okay, so let's see if this shows up properly. No, little more to the left. Still left. Oh man. One day I will figure out how to do this properly. Alright, good enough. We're around here. Okay, so this is 2005 C1. Are inequalities worth practicing for JMO? It's very hard for me to say much because I have so much control over what goes on the JMO and USMO, but I would say you don't need to practice it a lot, but you should know what AMGM and Kochi are and how to use them. Like, you shouldn't have like a total blind spot somewhere, because then if that problem shows up, you're just like, well, I guess I can't do anything. Yeah, I think it's good to test this kind of thing every so often. That's terrible advice, by the way. I haven't even made JMO. Oh, I mean, okay. If I had money, I would, yeah. I don't know how to make emotes that don't require a sub. But if you have enough channel points, then you can unlock a random sub emote. So, can you do Russia 2009? We probably won't get to it today. I think I'll figure out a way to allow problem requests in the future. As I start to run out of shortlist problems I want to do. Can I redeem the V-Bucks here for Alginite V-Bucks? What are Alginite V-Bucks? We should test these things every so often. Yeah. Amy number 12. There are too many methods? I think what happened was people learned what mirrorhead was, and there was a large class of inequalities that you could now just solve by expanding. I think what happened is like 3 variable inequalities died out because of that, because there was just this big machine called expand everything, and something happens. Okay, let me actually do the problem. So you have a bunch of lamps and rooms. So it's a graph, right? With exactly one other lamp. Each change in the switch. Okay, so it's a graph. Fine. Graph with even number edges. And what happens is So, well, this is a switch, and then there's a lamp. And there's at least 3 lamps in every room, so what that means is for all vertices, the degree is at least 3. So I have a graph where every degree is at least 3, and an even number of edges. I haven't even finished reading what the problem wants yet. This might be a bit premature. Number, edges, even. Room. I misspelled room, didn't I? I'll just leave it. It's funny. Is that an even number of edges? No. Can you make an Otis project rooms into smaller rooms? Okay, wait, I haven't even finished reading the question. Let me finish. And then you can toggle them and you want to exist in some of the switches at the end of which each room contains lamps which are on as well as lamps which are off. Oh, that's actually really annoying. Oh shoot. So every edge has oh lord. Oh lord, okay. Lamp problems. I feel like that would end up being the linear algebra unit, mod 2. Maybe not quite, but I'll think about it, but I feel like it would overlap too much with exist. It would be like linear algebra / algorithms. Like you would either have linear algebra mod 2, or you would have something like IMO 2008-5, which is, you know, you just kind of do it. It wouldn't be cohesive, I think. What about stone combo unit? I think that's similar. Okay. This is so annoying, actually. Oh my gosh. So the condition that there's at least degree 3, and there's self loops too. Okay, well the graph doesn't have to be connected, so I can just tag on connected components like this. Oh, shout out to Eric Wu. Thanks for the 500 channel points from 69 Legend. Okay, so the thing is, each of these... Delete self-loop vertices. Can I just delete them? Do I care? Do I not care about them? Oh, I see. Okay, yeah. You can just delete self-loops, that's true. In general, okay, we're going to go by induction. I'm going to go by induction on the number of anything. Induction on anything. Literally anything. Well, oh, delete self-loops is bad. Speedrun Alchemist. I think it would go real badly. Degree isn't at least 3 anymore. So the concern is if I delete the... Maybe instead of saying delete self-loops, I'll say think about self-loops last. Like if there's a self-loop, then we don't have to... We can kind of ignore that vertex until the very end. Maybe delete is too strong because it'll kill our induction hypothesis. But that's fine. But also, I have an even number of edges. What are these conditions? Oh, Lord. Because what's happening is for every edge, there's initially either an on or off. So like, let's say like this is on, this is off. And then I can switch it. Oh, okay. So there's 2 types of edges. Sorry. There's edges which are... Okay, that's a little more natural. So edges which are 1, 0 or 0, 1. And then there's edges which are 0, 0 or 1, 1. Thanks TRTJ Dumpling for the follow. Alchemist was an explicit word. Seriously. If you go by an algorithm, it's not a problem. Solving Olympiad question, the write-up is always very hard for me. Do you have any tips on how to write up? Practice. One thing is just get better. Like, I think write-up issues are actually usually tend to be math issues as well. Thanks to Namant12 for the follow. The other I think is to read other people. If you struggle to write up a problem, you want to see how other people wrote it up. Maybe I should preface this with how other people who are good at write-ups write it up, because most write-ups on AOPS are really bad. Yeah, I mean, get good is like fine. If the advice is get good, that means you just don't have to worry about it because you'll like it's not worth practicing specifically. I think that's what that means. Like you just keep practicing and you'll get better, and that thing will naturally become easier. I say the same thing about careless mistakes to some extent because like you make fewer mistakes on problems that feel easier to you anyways. So if you get better, you'll just naturally make fewer errors. Like, you know, you watch me do for the win. Okay, that was actually pretty bad, but like, you know, I didn't need anything on the for the win problems that like 13-year-old Evan didn't know. I was just better, so that was naturally faster. Thank you, Tree69420 for the follow. Who makes the best write-ups on AOPS that isn't you? I'm not going to say best. I will say anything by Canton Math Guy is probably pretty good. D. Grozev is almost always good as well. Thanks Ace of Flowers for the follow. I'm sure there's more. Those are just the two that come to mind right away. Yeah, Anant Mudgoal is pretty clean as well. How do you follow? If you have a Twitch account, there's a heart somewhere that will let you follow. All right, let me actually think about this. So there's a bunch of edges, and really, I guess I want to think about the edges as having different colors. So let's color the edges somehow. Dun 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 dun. So there's edges where there's opposite, and there's edges where there's the blue means same color, and then red means different color. So we'll say, or sorry, different state. And blue means same state. What is the Otis record for most units this year? I have to check. I don't remember offhand. You bet your name's good. I mean, they're user names. What am I going to say? Without log, all rooms are of size 3, 4, 5. Can you assume that? Degrees are all 3, 4, 5? Hmm. Anant Mudgoal. Did I mispronounce Anant? It doesn't work for star graphs. Well, star graphs don't satisfy a condition anyways. I do agree we should do something. There should be something in the form like the problem is true for so many graphs that if you have an edge that you can delete, it should be you can just delete it, but then you have to worry about the even degree. Wait, oh, sorry, I misread the problem. It's even number of lamps, not even number of switches. So I was just lying when I said there's an even number of. Oh, okay, I'm sorry. I'm really sorry. The number of edges is not even. So what that means, thank you, Biz. Oh my god, someone has named Bizwadev. Thank you, Bizwadev, for the follow. Okay, so if there's an edge that joins two vertices of degree greater than 3, every lamp has a switch. Yes, but every lamp shares a switch. So all this is saying is that the sum of degrees is even, I think. Yeah. You can just forget about... Okay, so you forget everything I said about edges even. This is great. If there's a vertex that joins 2 degrees of vertices degree greater than 3, then delete it. Good. Okay, so now in this diagram, let me... Alright, let me think this through. The forbidden word. What's the forbidden... Oh, Biswadev. Alright. I just saw misreading the problem. So I have a graph. Why is the condition the degree has to be greater than 3? Because if I drop that condition and I have a graph that's a cycle, then I run into problems, right? But 3 is somehow like... It just really annoys me there's 2 types of edges. It just makes it hard to think about. So like, for example, I can delete this edge. Okay, whatever. So let's start by looking at some vertex of degree 3. Thank you, Geico Lizard 9 for the follow. And there's some colors. And I want to do something. So 0, 1, 0. There's like 3 choices for what I can do. This is not clean. I don't like it. Maybe induct by changing the initial... Oh, that's actually not a bad idea. So you start by imagining all the edges are blue. And then if all the edges are blue, then you should be able to... Yeah, we should actually do the case where all the edges are blue first. That's actually important. So if all edge is blue, which I put in a red box, then how do I solve the problem? I want to... It becomes equivalent to getting like sort of directed cycles or something like that, right? You imagine if all the edges are blue, then... Sorry, I think the edges all red is easier. Which one did I say? Okay, let me make up my mind. Let's say blue is... I said blue is same and red is different. So if all the edges are red, then it amounts to saying in a graph where all the degrees are at least 3, I can orient the edges such that... You want an orientation such that no sink or source. So sort of like, what we can imagine is you just start trying to grab Eulerian cycles or something like that. So why are there 2 types of edges? The types of edges are joining... No, the vertices are rooms. So the edges join lamps of... Oh my god. Lamps connected by a switch have the same state. Oh wait, they do? No, they don't necessarily. The lamps connected by a switch have the same... Yeah, they don't necessarily have to have the same state. So I'm drawing blue edges if the initial state is different, and the same, and red if the initial state is different. Thank you, I'd1 for the follow. Yeah, I can't tell you show all blue. I'm thinking about all red, which is saying I have a graph with all degrees at least 3, and I want to get orientations. So my thought is I want to just kind of do Eulerian cycles or something. Cycles or paths or something, because you know the degree is so high. Thank you, Bizwadev Devroy for the follow. We're not going to get an A5, are we? So the all red case is you want to orient G such that it comes down to cycles, right? Yeah, so it's like I have this graph and all the vertices, all the edges are red. And none of the vertices are small degree. I really think the condition about, yeah. Yeah, I actually don't see how to do all red, which is really bad because we really should be able to solve this case first. Something like that. I think the condition that all the degrees is at least 3 is really messing with us because it's making it impossible to induct. I want to ask, are there weaker conditions for which the problem is true? And we try to induct on those. The reason you don't want... You can't have any leaves, obviously, because leaves will mess you up. Degree 2. What's a counterexample to the problem for graphs where the degree is at least 2 rather than exactly 2? Or, yeah, if I change 3 to 2, what's a counterexample for the all red case? Blue, blue, red. Okay. What if I make them all red? You have 2 lamps in a room that are the same. Oh, wait. Wait, oh, that's actually really bad. I forgot that the self loops... I see. I see. Is there an example that doesn't have self loops? Thank you, Binandev, for the follow. I'm getting a lot of interesting names here. Same room, the same color. Make it whatever color you want. Yeah. I like the local idea. You start with an assignment and you try to decrease the badness of the assignment. In the all red case, what does that do though? Like, let's agree to focus on the all red case because I think it's sort of the most natural case, and then we can try to worry about blue red. In the all red case, if you have one bad room surrounded by all good rooms, it's really hard. I don't know if it's necessarily that bad. Okay, actually, here's a suggestion for the all red case. So let's split it into connected components. All right? And then in each one, let's take a spanning tree. So if I take a spanning tree, then my graph with a bunch of red edges or whatever. I can root the spanning tree, that's fine. So it looks something like this. And then you go down. You just go down. And then you have some leaves. The leaves are the ones that aren't okay. But they go somewhere. So there's some more red edges I have to take care of. And I'm worried, like, I guess the case I'm worried about is if they loop to themselves. But there's at least 2 edges going out of each leaf, right? At least 3 edges, in fact. Yeah, well, one of them is the part of the tree, but I'm trying to think, can I run myself into problems? So if I have an edge that goes to a non-leaf, you can just forget about it. So I'm only worried about edges being shared. So the trouble case is if I have edges that are shared between the leaves like that, or something like that, then it's not, that's the only situation in which it's not obvious what to do. So the really bad vertices are things that are stuck inside. Thanks for the 5 bits, Ice Serpent. But in this case, if there's a cycle, then I can just orient the cycle as well. So let me make sure that works out. Um, this is, yeah, we're still working in the all red case, although I'm starting to see how this could work in a colorful case. But in the all red case, the only situation that's bad is if I have if I have cycles within off is overall number of on. Basically delete all cycles. I wasn't following the bad to good argument. Goes to bad from one angle. Basically delete all cycles, the result is a tree. Yeah. Anyways, does this work for the all red case though, this thing I'm writing with a tree? Because if so, I think it can solve the it might solve the original problem outright. It's like you take a connected component for the parts that are not the leaves, you can just deal with them. And then for the parts that are leaves, the only ones you're worried about is if you have a bunch of edges which are within a loop like this. And if there's a cycle, then you just deal with it. Put the edges of the vertices from the tree are still there. Yeah, but I think this should work for all red, is that right? Am I crazy? Thank you, I love Albert Wing. Alright, so this solves the all red case. Now, what if I'm in a situation where the edges are colored? So let's do like, let's draw the same tree for concreteness. So here's a leaf, here's a leaf. I need to scroll down here. Actually, yeah, I should just scroll here. So, okay, so now the edges of randomized colorings, whatever. Okay, in this case, I guess I don't want to call them arrows, but I think the point is, assuming we root the tree at any non-leaf, then I can just kind of greedy make sure that everything except the leaves is okay, right? So here, I said, what did I say? Blue is same, red is different. So here if I do 0, 0, let me do it in a different color actually, so it's easier to see. 0, this one, then we'll make this one 1, 1, and then we'll pick this one as 0, and then we'll pick, this one can be anything really. 1, 0, 1. So you go down on the tree, and everything's okay. And then this is like 1, 0. Sorry, 0, 0. Let's do 1, 0 here or something. Shout out to Yayaps. Thanks Skycode Lizard for a bunch of more points. Yeah, so again, there's leaves. Leaves are the problem. Again, there's some edges between the leaves and some edges that go to things that aren't leaves. If I have an edge that just goes to somewhere else, I don't care what it does because those guys are okay now. So I'm similarly, if I have any vertex, yeah, those are okay. So in the end, the only case you're worried about is cycles. Two regular graphs are disjoint unions of cycles. So in the leaves, you're worried about situations that look like this. You have like, these are all leaves. And there's like 2 or more edges. That's actually really annoying. I want to think, Because if it was exactly 2, you could get cycles in an obvious way. Deleting the cycles thing should still work. With slight modifications. I totally believe that. Is it... Actually, let me see. If you have a cycle graph, can you just do it? There's leaves and they have one state, and there's like... If I just do a random cycle like this, can't we just like greedy? I think basically, yeah. Once you get down to this. Shout out to Central North Carolina Math Group, which can be found at some random Discord link. If a room is bad, then swap it away. What do you mean swap it away? Just toggle one thing? I see. Yeah, actually, something like... So, I think this works even in the leaf thing as well. I guess it is one of those, you just do it. Like, say, let's take any leaf that's in the cycle situation. We pick this one as 0, and then we can just chase the cycle, right? Red is different. This is 1. So here I need a 0, and then I'll put a 0, and then here I need a 1, I'll put a 0. Here, 1. I don't even need the last edge. Okay, I actually... Wait, so is the problem this silly? Just anytime there's a cycle... Because I didn't do anything, so is this just... I have a graph. And then I cut open all the cycles to get a tree, and I just do it. What? So why is the condition that degrees at least 3 there? What? So why is the 3 condition there? Just because of the... Just for the self loops? Really? That's so bad. No. Okay. Spanning tree. Yeah, I didn't... So cut open all cycles. Yeah, okay. Alright. Okay, we're done. We're done. We did it. And the graph was completely bait. I guess that's what happens when you do random problems that you haven't vetted. Don't worry about it. Alright, let me set up the geo. Oh, I need to start GeoGebra.